That's good. So our story begins in April 2019, right before the world changed with the pandemic. They had big dreams in the UK of down at the Ministry of Defense's. They had already decided at this point that they're not building any more astute nuclear submarines, those fast attack submarines. They are moving on with ballistic missile submarines, of course, but the astute class essentially is going to end unless they change their mind, which they could. But they still need submarines in the Royal Navy without building more nuclear fast attack submarines. So the idea is to build unmanned underwater vehicles that can stay submerged for long periods of time. We're talking months eventually, and support the fleet that way in an autonomous capacity. And we have the technology in this day and age to have something like that. We just have to build it, test it, and engineer it. And that is all what we're talking about today. That's what the Manta program is this idea of shifting to an unmanned submarine force in the Royal Navy. Very exciting stuff. Now, granted, the astute classes will still be around for decades. They're not going away. They're just not building more of them unless they change that. Okay, I always like to have that caveat because this program could go sideways and they realize they need more manned submarines. I kind of expect that to happen, but let's just stay focused on the Manta. So what they did was, the process is very similar here in the United States, where there's a public board, and you can go to this website. It's actually public in the United States. It's called SBIR. It's a Small Business Incentive Resource or something like that. I forget what the IR stands for. And the government says, hey, we have this idea. We need proposals for, in this case, an extra large unmanned underwater vehicle, an XLUUV. And so they post that in April of 2019. 2019. But what they want to do to save money is the company that writes the proposal must already have a working XLUUV. We don't want a design. We don't want anything on paper. We want something that's working right now, so that that greatly reduces the cost of this project from the government point of view, because they have a working copy in which they can modify and build. And so this company, MSub, said, hey, we got something like that. They submitted the proposal, and they said the only thing that we got to do is make it autonomous, which it was already partially autonomous to begin with. So they're going to work on that. And then the department that's under the Ministry of Defense that wrote this proposal is called the Defense and Security Accelerator Program, or DASA. And they're the ones that actually manage it on the government side. So they got a couple proposals, and they awarded the contract in September 2019. That's only like a few months later, to MSubs. That stands for Marlin Subs here. And this is a screen grab from their website. Got their contact information there at the top. And they have two offices. Their main office, where they do a lot of the testing for this particular program, is in Plymouth, UK. There's an operating area just south of that where they do a lot of this stuff. And they also have offices in Rolling Rock, Texas. That was the little tease that I alluded to on the previous stream or previous videos on YouTube. So right here in the United States, in Texas, MSubs has an office where they do a lot of work. Granted, it's nowhere near the coast, so I don't think they're doing any submarine testing there. I assume that's all software engineers and people like that, because of its geographic location being away from the coast. But yeah, so Rolling Rock, Texas, a big part of this program, as well as their, primary headquarters in Plymouth, UK. It is a $2.4 million contract, and that is because they've already built the submarine. The UK didn't have to pay for the construction part of that, but they're going to modify this submarine, and that's going to cost about $2.4 million to meet the exacting standards that they had in the proposal. So it comes in two phases. Phase one is just basic seaworthiness and autonomy, which the S201, which is the base model for what the Manta will become, it kind of already has. Whenever it's on the surface, it's got a pilot, but whenever it's submerged, it's autonomous. So it's kind of getting there. But it needs to be able to navigate safely without running into other things, including the ground, grounding, while submerged. And that phase is already complete. Phase two, which is what we're in right now, is the UK is going to rent the vehicle for 2 years for more complex testing. Now, you may say, well, from 2019, 2021, that phase two should be finished, right? But of course we had the pandemic, which delayed everything. So phase two is still in progress. By public sources, It's not been complete yet, so who knows how long it's going to go, or if it is complete, it's just not public that it is, right? But the complex testing is more submerged testing with autonomous operation. And there's a lot of specifics that we're going to get into as to what it has to do to complete the complex testing. That's a lot of what we're going to talk about today. So M-Subs, or Marlin Submarines is the full name. They were founded in 1986. And what they do is design, manufacture, and operate manned and a lot of unmanned vehicles. And I've got some pictures here from some of the projects that they have in development. They have this surface ship that is wind-powered, solar-powered, and can go to sea for long periods of time doing autonomous duties. There is a similar American company that has a very similar contract, as you see here for the surface side of things, that is currently mapping the entire Pacific Ocean with a fleet of about 10 to 12 of these unmanned, solar-powered and wind-powered, wind-driven with a sail. It's got a little motor on it too, but mostly sail-powered, going around the Pacific. So they do very similar work to that, in addition to the unmanned underwater vehicles that we're going to be talking about today. These are all diesel electric submarines. So they got little energy cells or battery packs, depending on the variant, because they have different versions of this. The one we are talking about today will have energy cells. And like I said, Round Rock. I called it Rolling Rock. Rolling Rock is a beer here in Florida. And that's why I said Rolling Rock. It's actually Round Rock, Texas, is the other headquarters. Okay. So the proposal that M-Subs gave to the UK and won the contract was based on their S201 design. This is a submarine that already exists. They had already built. They had been driving it around Plymouth for a while now. And they said, hey, we've got what you need, Royal Navy. Do you want to go forward? And Royal Navy said, yep, wrote them a check for $2.4 million to modify the submarine you see here into what will become the Manta. All right, so as it stands, pre-modification, it's a 9-ton submersible that's 9 meters long and approximately 2 meters beam, or a wide. It can do 12 knots submerged, which is really pretty good, and has a direct drive electric motor, 1 4-bladed screw there in the center. Whenever it's on the surface, as you see here, they can plop a pilot on it and he can drive it around. And then whenever they're ready and they get it out of the harbor and ready for it to go autonomous, they pick the pilot up, close the little hatch there, and it can submerge and do its pre-programmed, testing. So right now, it's only got 48 hours of endurance, which is really good. Staying submerged, operating autonomously for that period of time is already a great achievement. And that's before we really get into the modifications that they're going to make. It can go down to over 1,000 feet in depth. And from design, like pen to paper, or in a computer CAD program, to being operational for the S201 was only a 14-month period. And that's really important because that means Marlin submarines are very good at taking their ideas and making them practical, functional, ready for testing in a very short window. They can move fast. They have a lot of experience. This company, like I said, has been around since 1986, and they've built a number of these types of vehicles. So they're very, very good at what they do. And whenever it's on the surface here with the pilot, they do about 6 knots. And basically, from what I could infer from the website, they use the human pilot to navigate around other traffic near shore and going in and out of port. But once they get offshore a little bit, the submarine can operate on its own, navigate safely. Now, the goal is to have much more than that. So here are the Royal Navy specifications of what they want. This is what they kind of asked the proposals to provide for them. And of course, the Manta didn't meet every one of them, but it got close enough to win the contract. So over here on the left-hand side, you have the baseline for the Manta. That, like we just said, it's 9 meters long, 9 tons in weight, good depth, 12 knots. But over on the right-hand side of the graph, you can see of what the UK wants. It's what Ministry of Defense wants. They want a sub that can be a little bit bigger. So if they need to, they can extend the hull on this, but no greater than 30 meters, which that's already a pretty long hull. Beam can be a little bit wider, 2.5 meters. Those dimensions are very important because if they do go long and wide like that, they can add more functionality and more power, more endurance to the submarine if they decide to change the dimensions of the submarine. The weight is limited at 70 tons or less. They're well below that at 9 with the current iteration. Operating depth is just a little bit more than what they have now at 350 meters. That's significantly below 1,000 feet. And then the endurance, this is the big one. They want this thing to stay at sea for approximately 400 hours and at that speed, or 3,000 nautical miles. So that's really the challenge there. They need to figure out how they're going to increase the endurance of this machine. One way of doing that is adding energy cells. If they do that, that's going to increase the weight, and that will probably result in increased size. And it's very early in the program, so we don't know exactly how they're going to tackle these, which is why we're probably going to end up doing a follow-up on this program in maybe a year or two whenever they have this thing hammered out. And that's assuming that they make it public as well, because we may not get any more information from this, because once it goes operational, they're not going to want to talk about it as much. But this is the future of, I think, all navies, including the United States Navy. Eventually, we will go to a mostly unmanned submarine fleet, and the UK is well on their way of doing it. They're ahead of the Americans in this technology. We have similar stuff here in the States we've been testing, but this program seems to be far along, in my opinion. Okay, so from the slide here, it says Manta has demonstrated the concept vehicle. It is fuel cell powered. That I don't know if they've already made that change. It does have 7-day endurance now with the 9-millimeter length. Again, if they added more power cells to it, energy cells rather, they could get more out of that. Automation is in development right now. Automation is very important because you have to learn rules of the road and then teach that to an AI so it can safely navigate without running into things. And for a human, that is instinctive. You don't run your sailboat or your submarine into another ship. But for a robot, it's like teaching a self-driving car, but with 3 dimensions, because you're submerging this thing and you've got geography on the bottom that you got to avoid. All those challenges are being tackled right now by these very capable engineers, mostly probably in Round Rock, Texas. So navigation is a big one. And then finally, because this will be a war machine, we need to teach this AI tactics and doctrine, taking advantage of that layer depth and those shadow zones, all those things that I've talked about in the past. This submarine, the brains of it, needs to understand those things because it's going to be at sea for 400 hours. So it can't come up to the surface and be like, hey, we got layer depth is now at 300 feet instead of 150. What do we do? Well, it needs to know instinctively that it needs to change its operating depth if it's trying to hide below the layer. And like I said, for humans, that's common sense. But for a machine, all that has to be programmed into it. Okay. And that's where machine learning really comes in. Machine learning is a very scary technology, but what it is the machine teaches itself how to take advantage of changing circumstances, changing variables, and how to maximize performance in a dynamic environment. It's not quite intelligence yet, but it is part of AI. It's part of becoming self-aware. And we kind of want to be careful with that. But that's where we're headed. That's the technology. And we're going to weaponize these things once we get there. All right, testing. Like I said, testing is underway right now. We know that much. We don't have a lot of details about it. But we do know from the proposal what they're expected to accomplish in this testing. And that is to carry, deliver, and recover payloads. So this has been done with divers, even deep sea divers, on ships like the Parchi and the Jimmy Carter today. This is being done by people, but now we're having these UUVs do this untethered. Untethered is huge. In other words, they're not being powered or even controlled by a mother submarine. They can communicate. Eventually, this will be able to communicate with other submarines and ships, but it is completely autonomous, and that's a big step forward. The payloads that it has, according to the testing, minimums, it has to pick up a 2 metric ton payload and be able to move around a payload that's at least 2 meters cubed or smaller, or I guess bigger. Yeah, at least a 2 meter cubed, which is a large payload. That's a big mass of something to move around. And if it's 2 metric tons, that's a lot of density. That's something that this thing is going to need a lot of power to just pick up and move around. Its primary mission, according to the website, is going to be initially intelligence gathering. So you can infer what that payload may be if it's intelligence gathering. I mean, the Russians have been doing this for years, where they drop listening devices near submerged telephone cables, or data cables now, technically. So this could easily do something like that. 2 metric tons is more than enough weight to drop those and recover those devices. It's also going to be doing ASW barrier capability. This is really how I think it's going to be employed early on. Not that it can't take and pick up intelligence gathering devices, but the shape of the submarine is very convenient for the Type 23 frigate. It fits in the Type 23's mission bay. So instead of having that, rigid inflatable hull boat, it could have one of these things, take it out to sea to its missionary area, drop it in the ocean off, right next to the ship, and let this thing do its thing for up to 400 hours or 3,000 nautical miles, protecting the fleet, essentially, looking for mines, looking for other submarines, So ASW barrier capability is going to be a big part of the future of this sub, and probably one of the easier challenges, in my opinion, compared to everything else it has to. And like I said, the pandemic extended the test schedule, and they have no details on that. We don't know how much longer this is going to take. Just know that this is in progress, and it's a very exciting program. I mean, if I wasn't sitting here talking about it, I would love to be part of it. That's how awesome this is. But they have very skilled people already on this, and they've made such great progress. I just can't wait to see what they do with this technology. All right, so force multiplier. This is a great view of its current iteration. Here you can see they've modified the bottom and have added a number of sensors here before we even talk about what its mission is going to be. But look at my cursor here. You can see that it has sonar sensors here on the front. These would be high frequency sonar sensors for close in, maybe mine detection. Obviously navigation's a big part. You got to look a little bit in front of you and down to make sure you don't run into something. But here, look at this big plexiglass-like window. You can see different styles of what appear to be cameras in here, or lights, or both, so it can illuminate the bottom. And, if you have a diver working with this thing could provide light and a video relay to another vessel, or just record what's going on down there. And then it has this could be a reflection, but there appears to be a large aperture something right here. That could be a floodlight for these cameras. I'm just speculating. I don't know. But here you can see this is a thruster, a bow thruster for lateral movement. So it's got that along with its main propulsion there. Fantastic photo. I'm surprised this is public, but it is. So we're going to talk about it. Great stuff. Okay, so it's going to work alongside the Astute class submarines. Obviously, it's too big to shoot out a torpedo tube and all that. I wouldn't be surprised if they had a cradle on the back of the sail, behind the sail of an Astute class submarine, or even maybe some kind of dry dock hangar that this thing could swim in and out of. Because in its current size, before it gets to 30 meters in length, before they modify the hull, it's small enough, apparently. It looks small enough to fit into something like that. The Americans, with our previous versions of XLUUVs, like DSRVs, which was manned, by the way, we just had cradles that it would sit on, strapped down to. In the 2000s, we did develop a dry dock submersible shelter that you can see on the back of some 688s and on on some of the SSGNs. Yeah. And those do have submersibles, but those are for special forces. It's very different than this. The point is we have the technology to take this device with either the Type 23 frigate or on the back of a nuclear-powered submarine, if it's secured properly, and take it to mission area and then release it. So I expect it will be working alongside the Astute-class submarine for that ASW barrier search. Additional fuel cells will give it up to 3-month endurance. That's one of the goals. Again, they haven't done that yet, but we're kind of projecting into the future as to what they want to do with this. And they're going to add a bunch of sensors to this thing. Here you can see they've already modified a couple of them. Unless this was part of the original S201. I'm not sure of that. But they're going to add cameras, sonars, even an electronic warfare suite. And that's interesting. If you can take this thing and somehow disrupt communications and sensors. Again, that entire topic is extremely classified. So we're not going to even speculate on how they're going to do that. Just know that the mission of this includes electronic warfare. And I'll have to let your imagination run with that. That's incredible. And then, of course, communications. It needs communications no matter what the mission is, but that's going to be part of the suite. And the so Type 26, I was saying Type 23. Type 26 and Type 31 frigate mission bays is where it fits. I'm sure I probably sent the UK guys into fits by calling it Type 23. Type 26. I'm still learning the names of the UK ships. Okay, and then autonomous vehicles are the best option for the UK, and that's more of a manpower and financial problem, is that they simply don't have like the enormous, budget and manpower that the United States has, for example. So they need to find these creative solutions, and I think this is a really good one. Modifying this S201 into the Manta program just makes sense. So far, they've done a great job of maximizing what they have into something that the United States publicly doesn't have yet. And it's still being made better. And we'll get to your questions here in just a sec. I'm going to go back and read the chat kind of at the end. Okay, guys? Let me just get through this. So here are my final thoughts on this and some more great pictures of this. You can see they've already modified it pretty extensively from what the S201 was. So testing continues in the SCXA. That's the operating area south of Plymouth. I thought about putting a picture of it up, and then I realized probably not a good idea to be broadcasting where these freaking operating areas are. So I did not include that in the brief. And you're welcome, Ministry of Defense. Yeah, your secret's safe with me, sirs. Expect to have this operational fleet in the next 10 years. That was part of their website. That's their goal, is they want to have this thing on board, whether it's being carried by the frigates or on the back of a submarine. It's going to be operational, though, by this time in the 2030s. And the whole idea of this concept, going back to the proposal put out by the UK, it's called fast to fail concept. And this is very interesting. They do this with more than just this program, where they're like, we're trying this, radical idea of autonomous unmanned submarines, but we want to, and we're going to put some money into it. But before we start developing a program that's 10 years long, we want to see if it's even practical. Do we have the technology to do it? And so that's why this fast to fail concept is to take something that already exists and has been tested and it works. That's the S201, and then modify it into what will be the Manta. And so a lot of that development risk has already been taken on by the private sector before government money gets involved. Very smart way of doing contracts. If they had done something like that with the Zumwalt and the Littoral ships, we wouldn't have a lot of the problems we have today in the United States. So it's a very smart way of doing business. And this is much smaller than Boeing's Orca 45-ton XL UUV. We do have an unmanned extra-large underwater vehicle, XXUV, here in the States. It's a very tightly kept secret program. Other than that, it exists. There's very little public information about it that can be verified. There's a lot of speculation on the internet, and I just chose not to include that in this brief because, one, it's not really on topic, and it is a lot of speculation. And so, but know that the United States, we got something going on, but of course ours is, McDonald's size. It's super sized. It's 45 tons, and it's probably pretty capable. But it's good to see the UK coming along with this. And yeah, really good program. Super excited about this. I'm really jealous that I wasn't invited to be part of it. Come on, guys. Let me in on this a little bit. And, anyway, great photos. Yeah, that's it. So yeah, I want to say thank you to, again, all the Patreons. Every one of you are awesome, and I really appreciate everything. But the top guys, Scott Borg, this guy is a freaking legend. He's so damn generous. Of course, Harpoon Henry and William R. Collier Jr. as well. On the division officer side, Alexander Huff, Brendan Ferry, Joel Corrent, DJS 4000, who's been around forever. A lot of these guys have been big division officer supporters for ages. Jordan Vazraka, Josh Warwick, Robert Stahl, thank you. Sean O'Neill, our very first, him and Scott Borg share this title of being our very first Patreons. And Fraser Disney, I do appreciate it. Now, I do know I want to make mention of one thing here for financial support.